Okay, let's jump in. Today we're going to unpack something that looks incredibly mundane on the surface. We are talking about a wire,
It's just a wire.
specifically the NTI E-2WO-500. And if you look at it, it's just a 500-foot spool of, gray cable.
It is the definition of unsexy tech, for sure. But in the world of environmental monitoring, which is what this is for, this cable is pretty much the only thing standing between a disaster and you actually knowing about it.
And that's our mission for this deep dive. We need to figure out what separates this particular cable, which costs around $325, from, say, some random wire you've got in a drawer.
Right. It all comes down to the engineering and really the reliability. If you start with the core, the source says it uses 22 AWG stranded tinned copper conductors.
Okay, so stranded I get. That's for flexibility, right? A solid piece of metal would just snap if you bent it too much.
Exactly. But the tinned part, that seems to be the real secret sauce here.
Why is that?
Well, copper is a great conductor, but it loves to oxidize, especially outdoors.
Ah, so when it turns green.
Exactly. And once it turns green, its conductivity just plummets. That thin tin coating is basically armor. It keeps moisture out, and the connection's solid.
Which brings us to the other big outdoor enemy, the sun. The spec sheet is very specific. It calls out a sunlight-resistant gray PVC jacket.
And this is where so many DIY setups fail. People think plastic is just plastic.
Yeah.
But standard PVC breaks down under UV radiation. If you just run a normal indoor cable across a roof, the sun literally shatters the molecular bonds in that jacket.
So it's like it gets a sunburn, becomes brittle, and then just cracks.
That's the perfect analogy.
Ugh.
And once that jacket cracks, moisture gets in, and that tinned copper isn't going to save you. This stuff is chemically built to just shrug off UV rays.
Speaking of the outdoors, I was looking at the operating temperature range. It's rated from -4 up to 221 degrees Fahrenheit.
That upper limit is just wild.
It's above the boiling point of water.
Yeah, you could technically boil this cable and the data would probably keep flowing. It gives you a massive safety margin for, say, a hot attic or direct sun on a black roof.
It was the lower limit that actually gave me a bit of a pause, though. -4 degrees Fahrenheit. I mean, that's cold, but it's not that cold.
That is a really sharp catch. If you're installing this in, say, Minnesota or parts of Canada.
-4 is just a Tuesday in January.
Right.
So what happens if it drops to -10? Does the signal just cut out?
The signal itself might be fine, but that PVC jacket becomes the weak link again. Below that rated temp, the plastic loses its flexibility.
So it could shatter.
Like glass. If the wind blows or something hits it, it could just crack wide open. So it's rugged, but it's not invincible.
Okay, so context is key. Now, what are we actually hooking this up to? The docs mention connecting dry contact sensors to NTI hardware.
Think of it like a nervous system. The NTI unit is the brain, and these dry contact sensors are like the fingertips. A dry contact is just a simple switch, open or closed.
So no voltage is actually being sent from the sensor itself. This cable is just carrying that simple open or closed status back to the main unit to sound an alarm.
Precisely. It's a very simple signal, but it has to be flawless.
Now, here's where it gets really interesting for me. The price. We mentioned this 500-foot spool is $325. But I saw in the same source list there's a plenum version, the E-2W-PLNM-500. Same length, same core function.
And the price is?
$750.
Wow. Less than half. That's a massive price difference.
So are we just paying an outdoor tax?
In a way, yes. Or maybe call it the cost of ruggedization. That plenum cable is for indoor air spaces, like in a drop ceiling. It has a high fire safety rating, so it won't spread flames, but it has 0 of that UV armor or weatherproofing.
So you're paying an extra $175 for the peace of mind that a rainstorm or a heat wave won't just sever your connection.
You are, and the RoHS and UL approvals that come with it. You're buying reliability. You could use the $150 cable on a roof, sure. You'll save money today.
But you'll be replacing it in 6 months when the sun eats it alive.
If you're lucky.
So to wrap this up, what this really means for you, the listener, is that this NTI E-2WO-500 isn't just a wire. It's a very specialized tool. It's expensive because it's engineered from the core out to survive in places that would destroy standard cable.
Absolutely. And it leaves you with an interesting thought, doesn't it? We spend so much time obsessing over the high-tech sensors and the data they collect. But how often do we stop and think that the reliability of all that critical data just hangs on the chemical formula of the gray PVC jacket that's protecting the wire? Sometimes the most important tech is the stuff you don't even notice.